Hey everyone, this video is going to walk us through your square root principle. We are going to look at numbers 7 and 9 from your worksheet. And so we have x minus 5 squared equals 36. And so when you see an expression and you have something that is being squared, so you have a set of parentheses being squared, naturally it's probably going to be easier to try and get rid of that square. And so some of you may say, well, I can just rewrite this as x minus 5 and x minus 5, bring the 36 over and factor, which you totally can do. It's a little bit of a longer process. So using that square root principle will help you out. And so all the square root principle says is if I have, let's say, k squared equals, we'll say y, then that means I can solve for k by taking the square root of both sides. And so that means that k is really going to be plus or minus whatever the square root of y is. Okay, and so it's really the idea that squaring something and taking the square root of something, they cancel each other out. So here I have x minus 5 squared, and I want to get rid of that square. And so I'm going to take the square root of both sides. And so that will cancel out my square. And so I'm left with x minus 5 equals, well, the square root of 36 is plus or minus 6. Right? My goal is to solve for x. And so I want to get x by itself. I need to move this 5 by adding 5 to both sides. And so just a little key is this plus or minus stays with the 6. And so I'm going to rewrite this as 5 plus or minus 6, right? And so we know that that plus or minus breaks down into 5 plus 6 and 5 minus 6. So this is going to give us -1, and this is going to give us 11. Okay, we're going to do one more example. So that was number 7. We're going to look at number 9, which has way more parts. So I have 4 x minus 6 squared minus 35 equals 14. And so the goal is going to be to find that value of x, okay, that will make this statement true. And so we're looking for our solution. And so the process is the same, right? I still want to get rid of this square. The problem becomes, well, I have this 35 here and I have the 4. And so just when you were solving linear equations, you want to move what's least attached. I want to do that again here. The 4 is connected to the parentheses, so I can't move that quite yet because this 35 is here. And so I'm going to add my 35 to both sides. I'm going to use the inverse of subtraction, which is how it's attached. And I'm left with 4 times x minus 6 squared equals 49. And so now I still want to get rid of that square, but now I have this 4 that I have to get rid of. And that 4 is connected to the set of parentheses by multiplication, so I'm going to divide. And I'm left with x minus 6 squared equals 49 over 4. And so I'm going to leave it as a fraction right now, and you'll see why in a second. I'm sorry, this should be squared. Okay, and now I want to get this x by itself. So I have this square I got to get rid of. And so the opposite or the inverse of squaring something is taking the square root. And so I'm left with x minus 6 equals plus or minus, well, the square root, well, both of these numbers are perfect squares. And so the square root of 49, right, this really can be written as the square root of 49 divided by the square root of 4. And so it's really plus or minus the square root, well, square root of 49 is 7 and square root of 4 is 2. And so this leaves us with x equals 6 plus or minus 7 over 2. And once again, that plus or minus can split, and you get x equals 6 plus 7 over 2, and x equals 6 minus 7 over 2. And you can do this in the calculator. Unless it tells you to reduce, your answer should be written as a fraction, and it should be 19 over 2 here, and 5 over 2 here.